Okay, guys, hello to the afternoon session of the first training day. So Usama is an associate he's a member of our staff on Middlesex University. His specialization is in networking, and working closely with Clifford as well. We have a significant proportion of our networking team here presenting. So again, Usama will be able to show you not only teaching subjects in networking, but also teaching practices that we do in the labs and so on. So hopefully, when we have you in London, you will be able to associate what we were covering today with also the infrastructure that we have in place, of course. And again, as I said to all the professors, we will have emphasis is on helping you. It's like a train the trainers, if you like. So how you teach a similar subject. So Sama, please emphasize also on teaching practices, and we're keeping in mind that our focus is also to equip students with sufficient skills also with the concept of the freelancing. So the idea is that how they would be able to work also in this field as a freelancer. Sadiq, if you can, I don't know, there is another colleague who's guest with an Arab name. So if you can actually put in the chat, what is the name? So at least so we know how to monitor, because
yes, in fact, I'm sending a message.
My Arabic is non-existent, as you know, anyway,
yeah,
especially the written one. Okay, so thank you very much, Usama. Thank you very much, colleagues, for the afternoon. So we will start. Usama will control the breaks. I will be in parallel, Usama, so I will still be online. This is why I'm remaining a host. Okay. And feel free to organize your breaks accordingly, and I can see Cliff actually is coming as well.
Okay, excellent. Well, thank you very much for that introduction. Good afternoon, everybody. My name is Usama Arusi, and like George just said, I'm a member of the teaching faculty at Middlesex. My specialty is computer networks and computer network security. I'm also, I work closely with Clifford, who presented early this morning. And I'm also a certified Cisco instructor in networking and routing and switching, and also in network security. And today I'm covering both two topics. One is network security. So we're looking at the actual network security and securing the network as infrastructure. And we're also going to be looking at the cyber security for the later on. So what I'm going to do is I'm going to have this session kind of into two halves. The first half will cover the network security. I'll go through some slides of how I teach, and I'll give you like a demo example of the sort of slides I would be going through with students for this sort of topic. And then I wouldn't be too long in there, so I wouldn't bore you too much. So I will go after that to a demo lab, and I'll try and actually go through a demo lab regarding the topic that I've just covered. And then we'll do a little break, just like Clifford did, give you a little break to kind of catch your breath and have something to kind of refresh yourself. And then we'll come back and we will do the cybersecurity. And it's the same kind of structure. I'll go through a little topic and some slides, and then we'll do like a demo lab after that. Okay, so let me share my screen to begin with. Hopefully everybody can see my screen now.
Yes.
Ready? All right. Okay. All right. So so let's start with the network security. I mean, network security is quite a broad kind of subject. So what I thought I would do is kind of narrow it a little bit and talk about one aspect of securing the network. And that is a well-known kind of topic to all, at least by name, if not technically by all, and that's firewalls. So implementing firewall technologies to try and protect your network. What I thought we'll do is we'll cover within this presentation what is, so introduce the firewalls, what are firewalls and what they actually do. We'll also be talking about how they work and what they use as of control or access control lists, or ACLs for short. Within these access control lists, we'll find that they have different types. So we'll look at the standard access control list, and we'll also be looking at the extended access control lists, and we'll find that for those two types there are yet another kind of deviation or separation, whereby one will be a numbered, where we will identify the access control list by a number, and another by name. And then we'll have a look at how these access control, what makes these access control lists, and basically they are entries or statements within the ACLs. And then we'll have a look, we'll kind of close in the session by looking at how the routers actually handle these ACLs as and when they do receive packets, to try and actually route them and forward them on. Okay, so we'll start with a little introduction. Okay, now as networks kind of continue to grow over time, they were increasingly used to start to transfer and to store within some sensitive information or sensitive data. Okay, now obviously depending on the type, I should say in quotation mark, type of business that particular organization or network is engaged in, will depend on how sensitive that information is. But nonetheless, because networks carry more and more or store more and more sensitive information now, this has intensified or made stronger the need for stronger and more security or secure technology to be able to protect that data. And this has led to the invention of the firewall. Now, the firewall as itself, in itself, is a term originally that is used to refer to a fireproof wall. So it's a physical, actual wall made out of bricks or maybe metal. And this is acted as a barrier that will prevent flames and fire from spreading to adjacent or structures or adjacent rooms. Okay. Now, network designers has adopted the term firewall, and they've used it within their own networks to separate protected areas from non-protected areas, or private networks from the outside. Okay, and this firewalls within networking prevents unauthorized users from accessing the protected network resources. Oops, this is not moving. Okay, excellent. Okay, now initially, basic access control lists that are used within the firewall to kind of limit or to filter packets as they go through these routers or this network, included standard access lists, extended access lists, numbered or named access lists. And these were only meant to provide firewall protection. But now, as you know, as firewalls matured, or firewall technologies matured and began to mature within in the 1990s, what we saw is the emergence of a stateful firewall. These are firewalls that use tables to keep track of real-time, the real-time state of an end-to-end session or an end-to-end conversation between two devices that are connected on a network. And these stateful firewalls, what they do is they consider the session-oriented nature. So what type of session that has, or that is existing, or that will exist between two entities within the network, or as it goes through the network. Now, ACLs, like I said, firewalls work with ACLs or access control lists. And these are mainly, they're used to kind of slow down the damage or try and mitigate the damage that could occur to network attacks by controlling the network traffic as it goes through the network. And we find that administrators use these access control lists to kind of define or identify traffic or types or classes of traffic on the network, network devices like the routers that are implemented on, so that they can meet certain security requirements and policies. And these will work throughout the OSI model, or throughout the layers of the OSI model, starting from layer 2, that's the data link layer, and that's obviously the layer that is used to forward traffic. Sorry, somebody.
Excuse me, Usama.
Yes.
Yes, Mohammed Hussein. Excuse me.
That's
access in the last point, you wrote access list can be defined for layer 2. Can we define the access list in layer 2 in switches?
Within switches?
Because we can put the access list on layer 3 because it's, for example, the extended access list or the other access list. It's not the source IP address or the destination IP address, so we can define them on routers and above.
Yes, but routers will work on layer 3 downwards. So a router will still have to look and identify and de-encapsulate packets as they come in to the interface from layer 1. That's the physical layer. So they will have to. So we can identify packets according to layer 2 entries on the MAC or on the data link header. So they don't have to work. It's not like the switch that will need the access list, although layer 3 switches will be able to actually.
Yes, I know that we can, for example, define access list on layer 3 switches, but we can define them on layer 2 on layer 2 switches without routing.
No.
Okay.
No. Because access lists will, they work on or within routers, okay? And like I said earlier, routers implement layer 1, layer 2, and layer 3, and they don't look at the above layers. So when we say we can define access lists or access control lists within layer 2, that means it's within the router is where the de-encapsulation happens, and that's where the filtering happens.
So it's not in layer 2. I have this understanding because I thought so you can implement access list on layer 2 switches. So I understand now.
No. I mean within the OSI model.
Okay. Thank
Layer
you.
2 within the OSI model.
Yes. Okay.
Understand? Yeah. Because it goes in now. Access lists have developed enough to be able to actually work within several layers of the OSI model. Previously or historically, we were just able to just use the source IP address or destination IP address, and that means it's just layer 3 filtering. However, now it's developed that we can actually filter from layer 2 up to layer 7.
So the first step in security, for example, a router to have the access list.
Yes. Yeah.
Okay. Thank you, Usama. Thank you.
All right. No worries. Thanks.
Much.
Okay. So access lists now can be defined throughout the OSI models from layer 2, 3, 4, and 7. Now, historically, like I was just saying to Mohammed there, historically, the type of access lists could be identified by a number. And as you can see in the table, they have different ranges or blocks of numbers to identify the type of access control list. Today, however, parameters have expanded somewhat, and we can use access control lists to identify parameters such as IPv4, IPv6, TCP and UDP ports, and so on, port numbers, and so on and so forth. We'll see a little later on how that is actually implemented. Now, access control lists, as they are, or as we take them, they're actually a sequential list, or a list that goes in a sequence, okay, to either permit or deny packets to either enter or leave a certain network or certain interface. Okay, so these are actual statements that are listed in an access control list, and these statements are called, or they're known by access control entries. Okay, and they work in a sequence, in a sequential fashion. Now, these access control entries, they can be created to filter traffic based on certain criteria. This criteria could be the source IP address, the destination IP address, the protocol that is used within, the port numbers it's destined to, and so on. Okay. Now, we have different types of access control lists. We've got a standard, we've got an extended, like I mentioned previously. But for standard access control lists, what they do is they match packets by examining the source IP address that is listed within the IP header field. Okay? And this makes it a layer 3 filtering ACL. Okay, so it for standard ACL, it looks at only the source IP address, and it goes by that, and that can only be found on layer 3 or the IP header within the packet. Now, okay, I'm just having a little problem actually flicking from one slide to the next, hence the actual slide delay. But now I managed it. So if we can actually see on the slide, we've got an example of a statement or an access control list for a numbered standard numbered IP ACL. Now, this is according to, this would be normally used on like a Cisco router, okay? And the way we actually configure it will be to write the commands in such a fashion, as you can see here. We'll use the access list command, okay? And this will identify that now we're identifying, or we are trying to enter an access control list within the router, and we need to identify it. Now, for a standard numbered IP access control list, the range is given between 1 to 99. So that's any access control list given number given between 1 to 99 will automatically be identified as a standard numbered ACL. So after access control list command is written, is expected that you enter a number between 1 and 99. Once that is identified, and that is used as the identification for that particular access control list, then we'll need to now specify whether to permit this traffic or this packet through to the network or through the interface, or to deny it. And to permit it will just means that you allow it through. Denying it means you're going to drop, or the router is going to drop that packet or discard that packet altogether. Now, we also have a remark as an option to enter here, and this basically just it adds a remark about the entry that the administrator is just going to enter after that particular command. Now, normally it's either permit or deny, depending on the security policy that you want to actually achieve on the router. What comes next is that you have to identify now where this packet is coming from. So if you're going to permit, you're going to say, permit packet coming from X destination, X source, whether it's a network or it's an individual host. So you need to type in after that the address or the source address. And this, if in the case of a whole network that's been identified here, this will need to be followed by what we call a source wildcard. And this gives parameters to the size of the network that you're allowing or you're denying access by this ACL. Okay. Now, that was the standard numbered access control list. We're also mentioned extended numbered access control list, and these have a different range of numbers. And these range normally between 100 to 199. They also have a different range, but the one that is being used most common is between 100 to 199. We also have between 2000 and 2699. And these will automatically be identified as extended ACLs. Now, the difference between the standard and the extended is that the extended ACLs, they give more flexibility in the control of the network access than the standard ACLs. Okay, what they do is they filter the traffic according to the source and the destination IP addresses. They also filter traffic according to the source and destination TCP and UDP ports, as well as filter according to the protocol type. So basically, they give more control, okay, over and more flexibility than the standard ACL does overall. Now, when we look at how an example of how an extended ACL is actually configured on the router, we can see that we have a lot more parameters that we need to enter to give this extended or this greater flexibility. So they all start with access list. However, now the number that will identify it will have to range between 100 to 199. So any number between those, and you as an administrator, you have full freedom as to what sort of number you use to identify that particular ACL. Following that, you'll have to either permit or deny the traffic. And then you have to specify now, we're not gonna just deny all according to just the IP, we're filtering a little further on. Now we're going on to layer 4 as well, for example. So we're saying the protocol, what type of protocol that will need to be looked at. For example, if we're using, if we're looking at the TCP connections, then in this case, we'll enter TCP here, and that will look for any packets that that is using TCP, and we'll see if it has a match or not. Now, following the protocol, we have to enter the source address, that where this packet is coming from. Okay. Now, the packet could be identified from the network it originated from. It could be identified from a particular host in a particular network, so we can pinpoint just one host from a network that we want to either permit or deny, or we can state, or we can say just about any packet. So we don't specify a certain network or a certain device, but we can say any device that comes in using this particular protocol, either deny or permit. And then we specify again the destination address. So we can specify here which network we will either permit or deny this traffic to go through, or we can specify a particular host, i.e. like it could be a server within a network that we need to kind of control traffic as it goes to that particular host or not, or we could just leave it open as to any. That means we're not specifying a particular device or any particular network. We just leave it open. Then we can still kind of give more kind of filtering to my ACL by giving the port number, or specifying a particular port number that will identify a particular application that is used on, in this case, layer 7 of the OSI. For example, a DNS or HTTP or any of those. Okay. Not only can I do that, but I can actually, within the extended ACL, I can now pinpoint an existing communication or existing session that is being used between two devices, one device that is on my internal network and another on another network somewhere. And by using the established command here, I am only and specifically allowing these particular sessions that have possibly originated from within my network. And if a similar session is initiated from outside the network, then in this case, I could just deny it. Yeah. So the filtering now goes deeper and deeper and deeper throughout my OSI layers as I use the extended ACL. Now, I've been talking so far about extended numbered ACLs, and I've been using a range of numbers to identify whether it's a standard ACL or an extended ACL. However, I'm able to actually use the named ACL, whether it's standard or extended, and this takes takes place or instead of using a number. However, when I do use a name to identify an ACL, then I'm having to specify whether it's a standard ACL or an extended ACL. And as you can see, I put in an example there. This is a standard named ACL, and it's configured in such a way. I use IP access list to identify, I want to create an access list. And then I specify that this is going to be a standard ACL. And then I give it a name. This name is any name of my own choosing or the administrator's choosing. Okay. So in this case, they've used a no access control ACL name for it. And then once I kind of give it a title with a name, then I go ahead and inside of it or within it, as you can see, the configuration mode has changed now. And now I can start putting my entries or my statements, my ACEs within that particular named ACL and start either denying or permitting any devices or any IP addresses or any protocols depending or according to my security requirements. Okay. Once I've done that, I'll just exit it, and then prior to enabling it, I'll need to be able to place that ACL on a certain interface. Okay, so whether it be an Ethernet interface or serial connection, it makes no difference. Now, ACL is made up of one or more ACEs or entries, like I've previously mentioned. And within these entries, I have to keep an eye out on certain rules or certain considerations when I'm actually working with these ACLs. Okay. Now, one of those is that I have a rule, especially for Cisco routers, is an implicit deny all. Now, what does that mean? An implicit deny all is a rule that is associated with the ACL that will deny any packet access or entry through the interface if there is no specific match within the statements that are listed above. So the ACL is made out of several statements starting from top to bottom, and the router is going to start looking sequentially at these statements starting from the top, and it goes right through until the end. If it does not find a match, whether be it a deny or a permit, so it doesn't find any match, when it reaches the very bottom of that list and it doesn't find any more entries in there, it will deny anything that is not matched within its list. That's the implicit deny all. And normally, when I personally try and work with ACLs, even though there is an implicit deny all, I tend to kind of put in the statement anyhow. I'll put in deny any at the end. So make sure that that is done. It doesn't hurt your configuration or how the access list works if you actually type it out rather than leave it or you forget about it. But if you do forget about it, it is there, the implicit deny all. Then we have the ACL packet filtering. Now, it filters for standard ACLs. The filtering only happens on the source IP addresses. However, the extended ACLs will, as we've seen in the slides previous, delves a little deeper, gives a lot more kind of flexibility. So we're able to go through the various layers, various protocols or port numbers and destination or source IP addresses and so on, okay? So it gives us a little bit more flexibility as to how we use it according to our security requirements. It's always working with ACLs, it's always best, first of all, to read carefully the security requirements that you've been asked to fulfill, and to read it completely, not just read it carefully, but to read it completely. Some statements or requirements, you'll find that what needs to go at the top of the entries is mentioned a little further down the requirements. So you need to be able to read it carefully. Now, another rule you need to keep an eye on is the order of the statements. What do I mean by the order of the statements? Now, first match. This means that ACLs have a policy of a first match when a statement is matched. So when the router looks in or looks at the access entries or access control entries within the ACL, and it finds a match somewhere in the top or in the middle, it no longer looks or examines the rest of the entries that is within the access list. Okay? So when it finds the match, it will look at the condition that is attached to that match. Is it a permit or is it to deny that particular packet? And it will automatically rules according to that condition, and it will not carry on by checking for any further entries on the access list. That's the first match. Second, negated statements. Now, what that means is we need to make sure that statements at the top of the access control list do not negate or do not cancel out any statements found a little lower down. Okay, because of the first match rule, if a statement at the top cancels out a statement that I need to let through a little further down the entries, then that statement a little further down does not get looked at. Okay, so and because of that, we need to make sure that when we put the entries of the access control list, we go from specific to general statements. I'll give you an example of that. We've got, let's say I'm placing this access control list that will filter my traffic, but I need to filter traffic from a certain network, and I need to deny all entries from that particular network except for a certain device. Okay, so if I want one particular device to have access to get through the network, however, the rest of the devices within that same network not to have access, then I need to make sure that I place my permit entry first before the deny entries. I don't know if I made that clear or not. Yeah? Excellent. Okay. The next rule that we need to keep an eye on is directional filtering. Now, ACLs can be applied either inwards or inbound inbound packets. That means packets that are coming towards the interface, or they could be applied as an outbound packets, and these are packets that are going away from the interface. Okay, and in this case, here we have to double check of the direction of the data that the access control list is trying to filter. And again, the security requirements need to be read carefully to know where to place that particular ACL that has been created now. Because if I create an ACL with all correct entries within, that should do all the requirements of the security policy. However, if I place it in the wrong direction, then it's not going to filter out the traffic as it should. And I find that the security of my network has been compromised. Also, I need to look at or keep an eye out for special packets. Now, these special packets are actual packets that are generated from within the router itself. They're not going through the router, but they are being generated within the router. For example, update packets for routing tables. These will be generated from the router itself, and these will need to be sent out to adjoining routers to keep the routing protocol up to date and to keep the network in convergence. Now, if I need these special packets to apply, or if I need the access list to apply to these particular packets, then I have to make sure that the security policy is enabled or activated in the adjacent routers. Okay. Otherwise, these internal router generated packets will slip through the net as it is. And third, when we modify ACLs, we have to kind of keep in mind that when modifying ACLs, obviously when I say modifying, that means there is already a pre-existing ACL on the router, but I need to make some addition or changes to it. Now, any new entries that I actually make on a pre-existing ACL will always be added to the bottom of the list. And because of my initial or previous rule to say that the access list is checked from top to bottom, and it's when there is a match or a filter match is allocated or located, then the rest of the list will not be checked. I have to keep an eye out, or have to be very careful as to what this new addition to my access list is going to create for me. Okay, so if I need it, if it's a specific rule that needs to go at the top, I need to make sure that I specifically add it to the top of my list rather than the bottom. But as a rule, any new entry for the access control list as it gets configured will be added to the bottom of the list. And access control list is processed top to bottom based on the sequence numbers. Okay, so each access list will have a sequence number associated with it. For example, number 1 is 5, or number 2 is 8, and so on. Normally they go on a Cisco router, there'll be 5, 10, 15, 25, and so on, giving a slight kind of gap in between, just in case there is going to be any sort of additions or modifying the access list, and we're able to slot certain entries between the already pre-existing entries. Okay, And then, okay, yeah, that's it. Now, we just have a quick look at how actual routers handle or work with these ACLs. Okay, now the direction of traffic, we said, through a network device is defined by either the inbound or the ingress or the outbound, the egress interface of the traffic. So is it coming in or is it going away from the actual interface? Inbound traffic, we refer to traffic that comes in to the router before the router is, or that packet is being processed by the routing table. Okay, so for inbound, the access list is checked against the headers of the packet that's trying to enter into the router before that packet actually is processed by the routing table or processed by the router to send it on its way. Obviously, if it's a match, then it's going to look for either a deny or permit, and then it is going to act accordingly. If there is no match, we're going to have a deny all, so the packet gets dropped. For the outbound traffic, it refers to the traffic that has already entered the router and has already been processed by the router and is being sent onto the exit interface to actually send it on to its final destination. So that's where the ACL gets activated and the packet is then checked against the entries on the access control list. Okay. Now, there's also a dynamic track or dynamically tracked traffic, and this depends on the type of the device and the ACL configured on that router. And the return traffic can be either can be dynamically tracked in that case. For example, I have let's say I've got a an ACL that will it will deny any TCP connections to my internal device. Okay, so let's say a server. Okay, so I will deny any TCP connections coming or initiated from outside my network. Okay, and I can place that entry on my access list that will stop any TCP connections trying to get in. But if I have a TCP connection that has been initiated from within my network, it will be allowed out. However, the reply will need to come back in towards the network. Now, by dynamically tracked, this means that the router is gonna start placing a marker or placing that particular TCP connection that has gone out from my network to the outside network on a special tracking table. Okay, so upon the return of the reply for this particular session, it will be checked on that particular table, and if there is a match within, it knows that this is a reply to a pre-existing session happening from within my network, and it will allow it to come through. However, if this TCP connection is coming or being initiated from a device outside my network, there the ACL will automatically stop it dead and it will discard that packet. Now, if we have a look at how the match actually, or how the router actually operates it in a little diagram, you'll see that packets here on the inbound, as they come in towards the interface of that router, they will be stopped there and will be checked against your ACL. And ACL is made of statements, made out of statements or entries, okay? And it'll look at the first entry. Now, the headers on, depending whether it's a standard or an extended, makes no difference here. It will look at the headers and the various parameters within the headers, and it will see if there is any match within my first statement. Now, if there is a match there, it will stop looking at the statements further below, and it will go immediately to whether we need to permit that packet through or deny that packet. Okay, if it's a permit, then it will allow it to go through, and then the router will continue to process that packet to send it on to its final destination. However, if it's a deny, it will immediately kind of drop the packet and discard it, and that's the end of the story for that particular packet. Now, if there is no match at the first line or first entry, it will look at the second. Again, the same process happened as in the first. If not, it'll continue to look on the third, fourth, fifth, until it reaches the last entry. Okay, and again, within the last entry, if there is no match there, it will immediately deny it, because there is an implicit deny for any packet that does not have any match entry or within the list. Okay, so any packet that doesn't have an entry within the list or not being specified will be automatically dropped. Now, if we have a look at the outbound outbound placed access control list, okay, so here the packet will come through the inbound interface. It will be processed by the routing table. Okay, so obviously, if there is no match within the routing table, then that packet is automatically dropped, and that's the end of the story. However, if there is an entry or there is a match within the routing table, it will carry on now to go to the its allocated interface that will carry it on to its final destination. But here at the interface, the router is going to check, is there an ACL or not? Now, if there is no ACL, then that's the end of checking. It will automatically goes through the interface and goes through to its final destination. However, if there is an access control list in place at the outbound interface, now it'll start its checking. It'll start to do the testing statement by statement or entry by entry, like in the previous slide. It will keep checking. If there is a match, it will see if it needs to permit this packet through or not. If it needs to permit it, that's the end of the story. It goes through. If there is a denial within that statement, then it will discard the packet and it will drop it. Now, at the end of the statement, obviously, if there is no match, then there is an implicit deny all, and the packet will be dropped anyhow. Okay, I think that will do for now. I don't think I'm going to add any more for the slides. I think what I want to do now is just give a slide kind of demo lab to practice or emphasize what we have just gone through the slides. So before I go, or before I start the lab, is there any questions to what I've actually been talking about so far? No? Excellent. All right.
Excuse me, Usama.
Yes.
Which is better, to put the access list on the outbound or the inboard?
Sorry, could you say that again? The importance of the access on the outside or outbound compared to the inbound, is that what you mean?
Yes, from as I understand, it's better to put the access list on the outbound from
And really,
your.
it all depends on your security requirements and the policy that you're trying to enforce. Because sometimes security requirements require that the packet doesn't or should not enter the interface completely. Okay, there is like, we don't want this to go through at all. And then what you do is you place it on the inbound. That's for traffic to try to get on to the router. However,
Okay.
yes, but on the outbound, in this case, we're trying to filter, for example, traffic that has already been originating from within the network, and it's trying to leave the network to go somewhere else.
And for a specific destination.
Exactly. You can have specific destination or general. You can have general destination, but particular specific protocol.
Yes, yes.
Yeah. So in general, inbound or outbound placement of your access list depends on where you want to actually put the restriction from. Do you want the restriction that needs to go into the network, or is it restriction going out from the network?
Okay, thank you. Usama, the last question, please.
Yes.
Why we are using the wildcard, not the subnetting?
So, sorry, the wild card.
The wildcard with the access list, not, for example, subnetting. The complement of the wildcard.
Oh, let me just get the. Okay, you mean on. Oops.
Yes.
These ones here, yeah? Wildcard.
Yes. Why using wildcard?
Okay.
Not the
Wildcard, it's because we're specifying a network, whether it's a destination or whether it's a source. We're just putting a network address. Okay. So when we put a network address here, we need to specify how big is this network. What's the range of IP addresses now that I'm either denying or permitting? And this is, it's very similar to the subnet mask in your networking. When you use your IP address, you have to use a subnet mask together with it to identify
Yes.
which subnet this particular device belongs to. So here with the wildcard, we use the wildcard to specify the range of IP addresses that we either identifying as a source or a destination network. Okay, because
Okay,
you'll see
you.
in my demonstration in a minute that that's not the only one. I mean, this is just a small little example here to see how the statements are written, but instead of putting or identifying a network, I can actually specifically identify a particular device. And in that case, I don't use a wildcard. Okay, or I can say, oh, I don't want to specify any devices or any network. I just want any IP address from any network to be able to access or to deny. And in that case, I don't actually use the wildcard. Does that answer your question, Mohammed?
Yes, this is my question. Thank you, Usama.
Excellent. Okay. Actually, what we'll do is we will see now in this little demo that I actually have put up a little lab of how we use ACLs, how to configure them, and how to place them, and the results that will happen when we actually do place them and implement them and put them in place. Okay. You can all see my my screen. I've got I have a packet tracer opened up with a some pre-configured devices already on it. And on the right-hand side here, I've just got the same thing, but it's just instructions that I normally give these out to students to kind of try and follow through. Okay, they may or may not include full instruction of how to configure the devices depending on their level and their skills. Okay, but as you'll see here, you can all see this, by the way, yes? Yeah?
Yes, yes.
Excellent. Okay, good. All right. So as you can see here on my Word document, I've got a copy of the topology of the network that I already have on my packet tracer. Okay, and packet tracer is a tool that you use in networking, used in Cisco devices, and it helps with learning and kind of debugging and so on and so forth. And we use it quite extensively in all our Cisco courses. So now let me just quickly kind of filter through my screens. Okay, all right. So in my instructions, I also have the accompanying addressing table of the configuration of this particular network that I have set up on Packet Tracer. All of these have already been pre-configured. Okay. Now the objectives of my lab here is to first to verify that I have connectivity between my devices that are already up. Then I'm going to use access control lists to ensure remote access to routers is available only to a certain device, which is my management device here as PCC. Okay, so I'm going to deny access for these routers to anything but my PC. And then I'm going to configure some other access control lists on my edge routers. These are router 1 and router 3 here, to try and mitigate some attacks that might happen on these particular routers, to try and safeguard the internal networks here and here. Okay, and then lastly, what I'm going to do is I'm just going to verify that these configurations that are put in place are working as they should. Okay, basically a little scenario here, what I've just talked about. Access to routers 1, 2, and 3 should only be permitted to PCC, which is the management station. Also, this PCC is used for connectivity to test connectivity to the server here, which is identified by as PCA. Okay, this server has been enabled with DNS, SMTP, FTP, and HTTPS, which are the normal kind of protocols and services that you'd normally find on a normal network. Now, a standard operating procedure for ACLs on the edge routers, these are routers 1 and 3, is to mitigate common threats, okay, based on source and destination IP addresses. Okay, and within this activity, we will create ACLs here and here on these edge routers, router 1 and router 3, to be able to achieve our goals. Okay, and then what we'll do is we'll try and verify this. Now, these routers, these devices have already been pre-configured, so we don't have to waste too much time. And these pre-configurations also include passwords to obviously safeguard these routers. This is the standard configuration that we normally put on routers, and these passwords have been given for me here, so I'll be able to use them to be able to access these routers. So I've got several passwords here to use, these to gain access to various levels or modes within the router, and this one here to gain access to these routers remotely using SSH. Okay. Now, first of all, before we start, what we need to do is, before we start configuring any ACLs, we need to verify that I do have basic connectivity. Okay, so it's asking me here to log into PCA, okay, and verify connectivity to PCC, okay, and R2. So I'm going to go into click on PCA. I'll just drop this down a little bit. Okay, so you'll be able to see everything. Okay, so by clicking on PCA, I get the interface as it looks there. So I need to look for the desktop tab to be able to actually find my various kind of applications that I'll be able to use. Here, I'm looking for the command prompt to be able to ping and check for connectivity between my server to my PC. Okay, so I have the command prompt symbol there. I just basically click on it once. I'll get what I'd normally see on my command line interface if I try and go onto my own PC. Now here I'll need to type in the command ping and then the address of the device that I need to check connectivity to, and that is 192.168.3.3, and just click return. Oh, hang on a second. I'll put in the wrong one. Okay, I've uploaded the wrong packet tracer. This has already been finished, so I'm not going to use this one. So apologies there. I'll just take that one off. And bring out the packet tracer that I need. It's just loading up. Okay, this is done. Okay, so let's see if I've got the right one now. Okay, go to desktop again. With command prompt, 192.168.3.3. And I'm waiting for a reply. It's trying to ping through. Now my first packet timed out, hasn't gone through. Second one timed out. However, I did get a connection with the third and fourth. Now the first two timed out, basically, the network is just loading up. My routers are just finishing their booting up. And when I've sent the packet or the ping packet from the server here to connect to my PCC, the network hasn't converged completely. There's still some information that is needed, like MAC addresses to be mapped to my IP addresses, and hence the first two packets, they're timed out. So, but the third and the fourth one came through. So if I try the same exercise again, I'll just retype the command again. I should get the full four almost immediately. There you go. 1, 2, 3, and 4. This proves that I have full connectivity now between PCA and PCC. Okay, that's my first test. Okay, my second test says from the command prompt, establish an SSH session with R2. So basically, I need to establish a session from here to here using SSH or remote access. So I'll do that by typing SSH /l, and then I'll give the user ID admin, and then I specify where I need this to be sent to, 168, and the address for router 2, I think is 2.1. Yes, there's 2.1 there. Now, this should let me through there, and it will ask for passwords to be able to log in. Because if you have a look, these have already been pre-configured on the routers initially. Okay, so if I hit return now, I'm asked for a password. I'll put in the password. Sorry, I've typed it wrong. As I type passwords on Cisco routers, the cursor doesn't move. So I don't know if I've typed or pressed the right key or not, but I'll find out if it actually works or not. So let's try it again. Let's go SSH 855, and it works. As you can see, the prompt now changed from C to R2. So I'm actually now within R2, and I can control R2 and configure R2 as I need to, or as I see fit. But I am actually sat now in front of PCA. So within R2, for example, I can go in and say, I'll go into the global configuration mode, and there I've changed it. So I'm able to actually do whatever in there. So let me exit that for now. I'm just testing to see if I have connectivity. Just by exiting, I'm back again within PCA. Now here, testing connectivity again says now I need to do it from PCC. I'll close this. I'll log into PCC. And same thing, I go into the command prompt. I'm on the management computer now, and I try to ping PCA. So I'll do a reverse ping now to PCA, ping 192.168, and the address for PCA is 1.3. And I immediately get a reply back. The 4 packets I sent are replied back to. Okay, so I have connectivity now from this device to this device, no problem. The next check is that I do have access to a remote access to router 2. It's just one of the routers taken as an example. So I will try to give admin, and the address is 168.2.1, and I should get a prompt to ask me for the password. If I enter the password correctly, hopefully this time. No. There you go. Okay, second try out. Again, as you can see, I've got the R2 prompt now. So I am within R2, but I am actually sat at PCC. Okay, so this test also is successful. The last test is to open a web browser from PCA for services that have already been pre-configured on my server. Okay, and one of the services is HTTPS. Okay, or HTTP as well at this moment. And I do that by just going onto the web browser. Click on the web browser, I get basically emulation of what the web browser would look like. And all I do now, the web service or web server is not being configured with a name or domain name. So I just have to actually put the IP address, and the IP address is 1.3, and I should get a web page. Okay, this has already been, this is the standard web page that is associated with the web service. I can change that anytime I want, but that's for another time. I don't want to waste too much time with that. Okay, but there again, this is successful. I've managed to get in. I got a page. So all my connectivity checks are through. Now I go to the next stage, which is part 2. Now to secure these 3 routers. Now I need to secure them, and the instruction says configure an ACL, and it gives me a number, and from the number I can see that it ranges between 1 to 99. So this is a standard ACL. Now, what I want this ACL to do is to block all remote access to these 3 routers except for PCC. So I need to configure them in order not to allow any access from PCA, but to allow access from PCC. Okay. Now, I will do that by using the command access list to be able to do that on all 3 routers. So let's start on router 1. So if I go to router 1, I go to the command line interface. And this is the first time I go in there, so I'll need to enter the password that have been provided for me at the top of the instructions. And for the first one, I believe it's CISCO-CONPA55. Okay, so I've actually managed to get onto the console for that router. However, I need to go onto the global mode for that router to be able to configure it. So I'll need to enable that to get in, but even that is again being secured by another password. This is a different password now, so I need to enter that. And again, successfully, as you can see, that the sign has changed, or symbol has changed from greater than to a hash. That indicates I am within the global mode for the for this router. Now, to do any sort of configuration or configuration changes, I need to enter the configuration, the global configuration mode. And to do that, I'll enter the command configuration or configure terminal. Again, it's changed now to R1 bracket config close bracket. Now I know I am within the global configuration mode. From here, I can do all my configuration on this network. And to the instruction says, use the access class. Now I can just about go ahead and do that. But one thing I kind of always encourage students to do is to experiment a little bit. And one thing with Packet Tracer, at this stage, they should have already be familiar with it enough to be able to use certain facilities. One of the facilities is the help. And the help is done by the use of the question mark. Now, if I enter a question mark here, a list of all the commands that are available to me to use within this global configuration mode will be listed for me. So if I enter question mark, like I did right there, the commands will start to be listed for me. There's quite a few commands, and there's still some more in there. But I'm interested, and they're all actually listed within the alphabetical order. So it's easy for me to find if I know roughly what to look for. So my instruction says use access class. And if I look down at the list, I find the second entry says access class. Access, I meant access list. And the entry is there, access list. And there is an explanation as to what this would do. It says to add an access list entry, which is exactly what I want. So I'm not going to look at any more of the list. So I'll just break that, and I will enter the command access list. And now again, I need to know what to enter after that command. So if I use the question mark again, it'll tell me what I need to actually put in after that. That way I will ensure that I am still on the right path and that I don't put something that is wrong. Because if I do that, it will not accept it. It'll say it's invalid or incomplete or whatever. Okay, so now it's asking for a number. This number is to identify this access list that I'm trying to configure. Now I can enter a number that belongs to either a standard access list or a number that belongs to an extended access list. And I have the ranges here, so I don't have to try and remember them or to remember what ranges they are. They're actually put down for me. The instructions ask me for a 10, so I'm going to use 10, and that's automatically says that it's a standard access list. Again, I enter a 10. And before I put or hit the return key, I'll just check again. Is there anything else I need to put? So I'll use the question mark again. And again, it tells me I need to enter, deny, permit, or a remark. Now, let's have a look at my instructions. My instruction says I need to block all remote access to the routers except for PCC. So I do have an exception here. If you remember the rules.
Usama,
yes.
I'm very sorry to interject at this point. One of the participants has raised an issue with not being able to see the text in the command line. So is it possible that you could go to the settings and change the font size on the command line? I'm so sorry to interject.
I'll try to do that. Let me see, because this is on the packet tracer. So
may I suggest, if it is not possible to change the size, maybe Usama, when you type, at least you say what you type.
Yes. Okay.
It's not ideal, but because we have the recording, it will help it out.
Yes. Yes. That will save time. I'll see if I can actually change or.
If you go to settings at the top of file preferences,
yes.
right, file preferences of packet tracer, not the actual. So you want a preference tab.
Preferences.
And if you go to font tab.
Yes, hang on.
And if you change the CLI font size.
Okay, let's do 12, see if that's...
And change the CLI font size. If you look at...
Oh, right, yeah,
so
it's the wrong
to the right, go, so increase that to 14.
Okay, let's see if
and
that...
the tooltip as well, to 14, just below that.
So it'll be all right, yeah.
Yes, okay, let's go for that, apply. And hopefully that should fix the problem.
Yeah, hopefully, let's see.
So if you open up again.
Okay, that's better. Yeah?
Yes,
excellent.
It is.
Okay, good. All right, I'll put it like that so I'll be able to actually see the steps and you can see the steps.
Well, I have the feeling that Clifford has actually faced the same problem before. Maybe.
Yes, it looks like it.
He felt like somebody who definitely knew what he was doing.
many times.
Many times happens.
Thanks, Cliff. Thanks.
Okay. Right. So where was I? After the identifying it, like it said here, my instruction says I need to block all remote access except for PCC. So remember, the exceptions need to go first, the specifics need to go first. Otherwise, if it finds a general, it will not look at anything else behind it. So in this case, even though the instructions immediately says block all remote, the mistake that a lot of students would do is immediately say block. I need to put deny like it says here, but then that will stop my access list working properly. So first I need to permit my PC. So after I say permit, again, I'll use the question mark, and here it's asking for a source. Okay, who does, where is this permission or this packet needs to be coming from? And because it's a specific host, I've been asked to do PCC. I don't want to leave it open for any other PC on that network. So what I'm going to do is I'm going to specify a host. And then when I do that, I need to put in the address, because if I check on the question mark, it says, give me the host address. The host address for PCC is 192.168, and it's network 3 and 3. Okay. Now, before I hit return, again, double check what there is to actually put in after that. And if I try and check, it says there's nothing else to put in. That's all I need to do for this first line or first statement. So I'll hit return, and that's the first statement. I am permitting PCC. Now I go back to it and I say, I need to block everything else because I don't want any access to this router. So again, access list, again, 10, but this time I need to deny, okay? But what do I deny? Again, here I have an option, either a certain network, deny any, that means any PC coming from any network, anywhere, or deny a particular host, okay? So in this case, the instruction was to block all remote access. So my answer here is easy, it's any. Okay, and again, I'll double check that there is nothing else I need to enter, and it tells me that that's it, that's the end of my command. So I'm going to hit return, and this time the access control 10 has been properly kind of configured with the two statements within, one to allow PCC, the other to block anybody else. But now that's not the end of it. I need to apply my access list. I need to put it now on the correct interface in the correct direction. So I'll need to go here, the instructions say, put this or apply this access list on the ingress, that means coming in towards the router on the remote lines or VTY lines. So I need to first go onto the VTY lines. So I access like that by typing VTY, line VTY. Within the routers, I've got 5 lines, and they're numbered between 0 and 4. So and it doesn't specify here my instruction. So I need to put this access list on all the VTY line. So I'm going to specify from 0 to 4. I'll enter all of those lines. And as you can see, the command line has changed now. I am within the configuration mode of the VTY lines. And here I need to enter or apply the access list. It's telling me on the instruction, use access class. Again, I can do that blindfoldedly, or I can just quickly check what is that command actually exists. Can I use it or not? And I always do that. I encourage my students to do that, to be able to double check on themselves. It's very easy to make a mistake, and then you wouldn't know where to start from to be able to debug it. And as I can see here, it says access class. That means it is there. So I'll use it. And what do I need to put behind that? Because it doesn't really tell me anything else on the command line. So I need to find out. So I'll use the question mark again. It's telling me, all right, which access class, which access list you mean? Give me a number between 1 and 199, or give me a word or a name of an access list. But the access list I've been working with has a number, and it's a number 10. So I'll put in 10. Again, before I hit return, I'll check what else do I need to put, because that's not all the instructions to apply. So I'll hit question mark, and it's telling me, put the filter on the inbound or the outbound, whichever you want. My instruction says, don't allow anybody to get in to the network using these remote lines. So my instruction needs to be in. So it'll stop any traffic trying to get in. And if I see if there is anything else, I'll find that there's nothing. So I can hit return. And that means I've configured my access list. I've actually applied my access list on router 1. I can exit this interface, and what I'll do is I'll need to do it on router 2 and router 3. But before I actually do that, very quickly, let me just check, okay, if I'm able to do that with I'm able to actually log on to router 1 from PCC. So it's establish a session. In this case, it's asking for router 2, but I'm just going to change it quickly to router 1 because I do have the same privileges. So on router 1, I'm going to look for, I've already written the command to access router 1. I just need to change the IP address. Okay. Now, once I hit the return, I'm getting a password. That's very clear sign that it's going through. Okay, so I'll put the password to double check. Let's go SSHPA55. And once I do that, I find the prompt has changed to R1. That means I have access from PCC. So far, the access list that I put in works fine. So I'll exit this and I'll do my second check, which is establish an SSH session from PCA. Now this should fail. Fingers crossed now I haven't done anything wrong, because sometimes that happens. I'll just need to change the IP address because I need to go to router 1, hit return, and what do? Connection refused by remote host. Yeah. So this tells me that my access list that I've applied on router 1 is working fine. Now I need to duplicate that for 2 and 3. So I'll do that. I need to enter the password. Sometimes it's irritating to try and do that, but it's a necessary practice, especially when you're teaching security. Otherwise, it beats the point. So I need to enter the configuration mode. And now exactly the same. I need to allow this and then block this. So access list, and it's 10. And if you have a look, oops, wrong one. It says permit or deny. So I need to permit to begin with. Permit what? It's a host. I need to put the IP address of the host, which is 192.168.3.3. Check that nothing else needs to be put. So that's the first one. Second one, just use the up arrow, just kind of brings back what I've written. All I need to do is change the permit to deny. And then if I check what else needs to be denied, the instruction was deny all. So that's any. Okay, and hit return. Now I need to apply it. So line VTY 0 to 4. And then I need to apply this with access class number, and again in the in direction, and that. Just a quick test with my router. So I'll just change to an addressed 2. And again, you can see it's refused. With this PC, I should get connection. Just change the IP address, and it's asking me for a password. And I am in. So works again for 2. Just quickly do it for 3. It is time consuming, but it needs to be done. So it can't, there's no way around it. And enter the mode, Cisco 855. These passwords I'm entering are actually at the top of the instructions, so they're there. I'm just kind of trying to go quick so I don't waste too much time. Access list, and it's permit, and I need to permit a host with 3.3. Nothing else. Good. Now 10. I need to deny and deny any. Okay, now just to apply it for these lines, access class 10, and it's in. Okay. I'm not going to bother to double check it on this one. It worked with the other two. So now I've applied my restriction to all my 3 routers, as in part 2, and I've checked them. Okay. Now I go to part 3. This time I need to start limiting the access that I will give to my server. My server gives services for DNS, for SMTP, for FTP, and also HTTPS. Okay, and these are all the services within my server. So I've got HTTP, it's enabled, DNS is on, FTP, where is it? FTP is right here, is on, and HTTP, as you can see, and HTTPS is available. Okay, so what I need to do is now create another access list, but this time I need to put it on R1 here to limit access to my server. Okay, so my device that I need to work with is router 1. You can see it here, it says R1, but I need to read the instructions carefully before I go ahead and do it. So I need to create an access list. This time, this is it's numbered 120. It tells me that this is an extended access. So it gives me a lot more filtering, okay? Because I do have certain protocols, I might need to actually filter some and not others, okay? Now, instructions say, permit any outside host to access these services, DNS, SMTP, and FTP. However, I'll need to deny any access to HTTPS on the same server. So permit those 3, deny this HTTP, and also permit the PCC from accessing or logging onto R1 using SSH. Okay, now I need to do all of that, and the steps to do them are here. Now, before I actually go ahead and do them, just a quick verification that things are working as they should, so we can see the difference afterwards. So first, we need to verify that PCC can access PCA using HTTPS. And I do that. Now, before I do that, I need to disable HTTP. So I will only leave the HTTPS active. Okay, and I can do that using the services. I can see HTTP here is on. I'll just turn it off. I'll leave HTTPS on, and that will now limit my access. So if I just double check, I go to the browser and I type in the address 168.1.3. This will try and access the HTTP on the server. And if I try that, I'll find that it's not going to let me through. It will time out after a little bit. Okay, little time goes by, tries to get through. It says request timed out. So it's not going to work. So let me try it again. This time I'm going to try HTTPS, like it's asking me to do here. So I'll specify HTTPS, and I'll put in the address of my server. And straight away, I am getting service from HTTPS. Okay, so this is verified now. I am able to access HTTPS. Remember, it says here, second line is deny outside access HTTPS. So after I use this, I shouldn't be able to get this page after I apply my accesses. Okay, that's why I'm doing the check to begin with. Okay, now I need to configure my access control list, and this will happen on my router. As you can see, if I leave the router long enough, I'll have to continue to access it using the password. So I need to do that. Okay, So that is done. Okay, now I need to use exactly the same command as in the standard access list. However, now my access list number changes to 120, okay, because that will specify this is an extended list. Now, the difference here, if I use the question mark, the difference is in what I actually put in after, or in what type of filters I need to specify. The first filter says, tell me, do you deny or do you permit the packet? So in this case, I would say here it says, if I read the instructions, configure ACL 120 to specifically permit and deny the specified traffic. Specified traffic a little further up is permit outside host to access DNS, SMTP, FTP. So let's start with DNS. So I need to permit. Okay. What after permit? Question mark. It tells me, as you can see here, okay, I need to permit one of those protocols. Now, DNS normally works on UDP. It does work on TCP sometimes, but as a norm, it's UDP. So I'm just going to use UDP as my filter. Okay. Once I've used that, I'll see what else do I need to do or put down as a filter. Use a question mark again. It tells me put down the source address, okay, whether it's network, any, or host. The instructions here says permit, here it says any outside host. So it doesn't specify any particular number, host number, or any network. So I'm going to use any in this instant and check again. What else now? I'll find some more load of instructions coming up. It tells me put in a destination or put in an equal. I need a destination. Where is it going to? Okay. Now, it needs to go to server A or PC A. So I'll put in a host because I need to specify a device now. So I'll use a host. And with the host, it tells me what's the host IP address. I'll put the host IP address is 192.168.1.3. And then again, check what else do I need to do? Question mark. It tells me now I need to put in one of those. Let me just make it a little bit longer so you don't get the break of line. Okay. Now, one of those commands gives me further filtering with regards to port numbers, which I will need to identify these services on the server. Okay. And with DNS, I know it uses port 53. So let's try and use a match to any port or any given port. So I'll use the EQ command. Okay, so EQ. And then I say, okay, what next? What's after EQ? It tells me, right, you can put either a port number, and I've given a whole big range there to put, or one of the other commands there. I'm not going to go through these a little further out to what we need to do now, but there's also SNMP, there's TFTP written in here, which are some services that are given with their port numbers. But I know what DNS port number is. It's 53. So I'll put in 53. I'll check. Do I need to put in anything else after that? It tells me no, nothing of any consequence that I need to put in. Match packet to a given DSCP value or to a precedence value, which I don't have. So I'm going to leave it as it is. And that's marked by the CR in the greater than and less than brackets there. Okay, so I can leave it as it is. And once I press return, if I made a mistake, now the operating system will immediately tell me, okay, that there is something wrong. But if it comes back to the same global configuration command, that means it has accepted my entries and it looks like it's correct. So I've done the first permit for DNS. I need to now to do the second permit for SMTP, okay, and this one uses TCP, I believe. So I'll need to use the same access list number. I need to use the same permissions, which is permit. However, now my filtering needs to happen on TCP and not UDP. So if I enter TCP, again, it's going to ask me for source address. And in this case, it's any, because it says allow any, and it's asking me where is it going to. In this case, is that server. So I'll need to put in a host with its server address, which is 13. Okay, I need to be very careful with the address, especially if they're very close numbered together. It's very easy to make a mistake, and then you think you've entered the right address and it hasn't. Hopefully I have. We'll have a look at the end to see what happens. Now, what's after that? I need to filter it still further using the port ID. So I put EQ and I see what else comes in after that. I can either put a port number, or I can have, if you have a look further down, I do have SMTP here already written out for me, so I don't have to put port 25. All I have to do is just put SMTP, and it does accept it. Okay, to check if there is anything else. Oops. After that, and I found there is nothing else I need to do, so I hit the return, and SMTP is done. FTP, again, FTP is within the TCP connection, so you can see it, it's right there. So all I have to do is just change the very last instruction for it. Instead of SMTP, I'll just put FTP, okay? And that means those three statements for permitting DNS, SMTP, and FTP have been written successfully. Now, the next command I should do is to deny any outside access to HTTPS. So again, access list 120. This time it's a deny, and I need to check. Deny what? HTTP works with a TCP connection. So I'll specify TCP. Again, which source? It says any. So I need to specify any. And again, now it asks for what's the destination. Destination here I'm asked for is PCA. So I need to put in host, specify the address, 13, and then see what else. It asks me now for, again, port number of HTTPS, it's 443. Normally students, when they ask, oh, how do I know the port numbers? I say, well, easy, just Google it. If you Google it, you'll find it. You never get lost with Google. Okay, so EQ, whoops, EQ, and then see what else. And it asks for the port number, 443. See what else, is nothing else. There you go, it's accepted it. So the second line is successfully done. Now I need to permit the PCC connection to R1 via using SSH. Okay, again, the same access list, 120. Okay, and I'll need to permit this time. I need to permit TCP, because it does use TCP, and it asks for the source address. This time my source address has been specified as PCC, so I can't leave it as any. And in this case, I'll have to use host to specify just one device. And the host, I need to put in the address because it asks for the source address. In this case, source address is 192.168, and it's on network 3, and it is IP3. Okay, and then what next? Now I specified the host. I'll see what else I need to do. I need to specify destination. Destination now is the router. Okay, and the router on router 1 is host. Yeah, it says there. Let me just say. I was just going to point with my finger, and then I realized that you guys won't see my finger. So I need to specify the host. Okay, and then it will ask for host IP address. This time the router's IP address is 192.168, and it's on the 1.0 network, so it's 1.1. We can double check that very quickly before I actually hit the return by looking at the address table. It's right there. Okay, so that's 1.1. Okay, what else I need to do in there? It's asking me now what port. Now, SSH works on port 22, if I'm not mistaken. Clifford, are you still there? No, Clifford has gone away. I believe it's 22. I will just quickly check it out on my Google. Okay. And let's quickly say, okay, it's port 22. I was right. Okay, so here I will say EQ, and I will specify port 22 and enter. So now my third permission is done. Okay, so as in step 2, it says configure ACL 120. Yes.
Port 22 for which application?
This is for allowing PCC to access using SSH. Yeah.
To allow
Yes,
PCC to
because it
access
says,
the
yeah, it says permit PCC to access R1 using or via SSH. And SSH uses port 22.
SSH using port 22. Okay, thank you.
Yeah. Okay. All right. So step 2, I've done all my permissions, my denials, and I've created it. Now it's asking me to apply it, because creating it and not applying it will not make the access list work. So I will need to apply it on interface 0 S000. That will be the serial interface there where my cursor is actually hovering now. Okay, so to apply it, I need to enter within the interface, and the interface is 000. And as soon as I enter in there, you can see the prompt is changed. Now I'm within the interface, and I need to apply it using IP access group. So let's check if IP is there. If I have a look using the question mark, use the question mark. If I have a look down, I can see IP command is actually available. It says interface internet protocol configuration commands. So that's the one I need to use, IP. But it says after that, access group. What's after IP? Use the question mark again to see if anything like that is available. And hey, again, hey presto, there's the first one, access group. Okay, so I'll just put access group in there. But now my instructions kind of stopped. And this is where my students keep coming back. What do I do after that? I said, well, look, don't panic. Use the question mark. See what you need to put in after that. So access group, normally is you need to identify it. So you need to use question mark. It says, give me either a word that means the name of the access list that you've created, or the number that you've associated with it. Now the number associated with it is 120. Okay, and then again, what do I do? Use a question mark, and it tells you to put it in either in the inbound or outbound. Now before I put it there, I need to double check my command, my logic. Okay, it says use the IP access group command to apply the access list to incoming traffic. So traffic has to come in to the network, and therefore here it says inbound packets. So my answer here will be in. Okay, and before I hit return, double check that nothing else is needed. Use the question mark again, and again, nothing else is needed here. So if I hit return, it accepts it. That means now it is applied. So I can exit that mode, and I've successfully done step 3. Now it says step 4, verify. So if I'm verifying it, I need to verify that PCC cannot access PCA using HTTP. If you remember initially, when I accessed the HTTPS from PCC, I was successful. This time, I should not be successful. So enter the browser, specify that I want to use HTTPS, and I give the address because I don't have a domain name, 613, and I hit return. I already hit return now. The page should have appeared in front of me if the access list wasn't there. Now it should stop it. As you can see, it says timed out request. I can't access. And that is because I've used this here. It says, deny access using HTTPS. Okay, so number 3 is done. I go to 4. I've done for router 1. I need the other router here to protect it against attacks coming this way. Okay, now with, hang on a second. Okay, I haven't finished with R1 yet. It says modify an existing ACL. Remember when I was talking about modifying ACLs, any statements I add to a pre-existing ACL will go right at the very bottom. So if I am specifying or I'm entering a specific statement that will either deny or permit a certain device or certain subnet that has been previously already entered into a statement on the top of the ACL, then that will not work. Okay, so unless I am entering a general statement which needs to go on top of these permissions and denials I've already done, I need to be very careful about where to place this new modification. In this case, it says permit ICMP. With ICMP is another protocol, so I haven't used it previously, so it shouldn't really matter where it goes along the ACL. So I'll go back to my router. I'll go back to my existing ACL, access list 120, okay, and I'll see what I need to do. In this case, it says permit ICMP echo replies and destination unreachable messages from outside network. So I want to stop anything coming back, okay, into where is it? Into the network, okay. Allow any replies coming back, okay, into the network. However, I'll need to deny all other incoming ICMPs. Okay, so let's deny the first one. Let's permit the first ones. Okay, so I will permit, and then I use the question mark again. This time I'm using ICMP, and with the question mark, I find that ICMP protocol is already listed there. So all I need to do is type it out, ICMP, see what else I need to put in. It says, give me the source. Now, permit from outside, okay? Permit ICMP replies coming from outside, meaning from any direction outside, okay? So say any, see what else it needs. It's asking for a destination. Now, normally, if I'm just using, if I've got loads of devices here within this network and I've got them simulated here, and I don't want them to be interfered with within that particular ACL, I will identify a particular host. In this case, I've only got one, so I can do either. I can say host and identify it, or I can say the whole network and I'll just leave it open, okay? Whichever it is, okay? So let me do host in this case, which is PCA, because it's all going to the PCA server. So I'll say host, so source, destination address will be the host, 192.168.1.3, and then see what else I need. Now within the ICMP, I can choose whatever I need to permit. I'm permitting any returning host, and it's asking me for echo replies, and I need to specify echo reply here, echo reply. And I say again, what else do I need? It says nothing. That's all you need. Okay, I've done everything. So I'll say, okay, thank you very much. That will do for the first permit. Now I'll need to also permit destination or unreachable replies to come back. So if I hit the up arrow, the same statement comes in again, okay? And I just take away the echo reply. Now I need to put in something else. If I have a look at my previously asked help, I find unreachable for any reason, unreachable, okay, will be allowed through, okay, if there is a fault somewhere with that pinging. Okay, so I'll just put the unreachable, okay, and hit return. So I've done the two permits for echo reply and unreachable. Now I need to deny all incoming ICMP. So anybody trying to ping my server from outside the network will be denied. So in this case, I'll say access list 120 deny. And again, deny what is ICMP. And within ICMP, I'll say what? They say the source. Who do you want to deny from? I'm going to say all, because it says all other incoming ICMP. So that's any. Okay. All right. You denied anybody, but where is it going to? I need to say, all right, it's going to that server. So it's host, server address 192.168.1.3. And okay, we know where it's going to. What do you want to deny? And in this case, I want to deny any pinging, anybody trying to reach out to this server. So it's the echo here. Okay, so echo, and check if there is anything else. There's nothing else. So thank you very much. That is done. So I've done the statements for the modifications for the statements. It says verify that PCC can successfully ping a PCA. So let me check. I've put in the statement, okay? I'll double check also my my configuration commands, just to double check. These are the statements I've already put in there. All the permits that I used to have, this is for the DNS, this is for SMTP, FTP, HTTPS. I've also allowed SSH here for PCC, okay? Now, these are the extra ones, the new statements that I've put in. Just put them up like that, okay? Permit ICMP echo reply to come back. Permit the unreachable to come back, but deny anybody trying to ping my device. Okay, so according to my list, it's working fine, and it is already been applied. So I don't have to redo it again. It's already there. I've just modified it. That's all I've done. So now they're asking me to verify that PCC can successfully ping. Now, what do you think? Do you think it can successfully ping? I've said, stop any pinging here. I shouldn't be able to ping from there to here. Let's have a look. I'm going to say ping 192.168.1.3. As you can see, says unreachable, unreachable, unreachable. Okay, everything is stopped right there and it's not going anywhere. Okay, so a reply goes back, well, you can't reach this server because I've put in an access list there now to stop anything going in there. Okay, now, what if I try and ping from here to there? Desktop. That should go through. Okay. 192.168, and it's 3 and 3. As you can see, I'm getting replies back with round trip times and everything else. So it's successful going out. I'm receiving replies to say everything is okay, but if I try it the other way around, it's not happening. Okay, now, done that, verify the PCC, that's it, okay, that one is done. Now, this has been done and modified for PC, for R1. I need to go to R3 now to create another access list to stop any attacks going onto this network here. So I need to work with PC router 3. I need to enter the password. Let's go enable 855. Okay, and think. Okay, I'm ready to go there. Now let's have a look. It says create a numbered IP ACL 110. Again, this is an extended access control list, and it needs to go on R3. I am on R3. Says you need to deny all outbound packets with source address outside the range of the IP address of the internal IP addresses on R3. Internal IP addresses on R3 is here, 192.168.3.0/24. So I know what they are. Okay, so anything outside, I've got 10.2.2.0, 10.1.1.0. I've got 192.168.1.0/24, and I also have another one here, which is a loopback address, and that's again just signifying another network up here. If I have a look at it in the access, the addressing table, R2, there's a loopback address. It's right there. It's 2.0, and again it's /24. So there is a 254 addresses associated with that. So that as well needs to be included. Okay. So number 5 there, I need to deny all of those networks access to this router here. Okay, so that's how I understood it quickly. So first one, configure ACL 110. So access list 110, and I need to permit only traffic from inside the network, meaning I will permit only inside traffic, deny all from outside. So permit traffic with IP, not specified as any sort of protocol. So all IP packets, source address, I'll give that network there, which is 192.168.3.0. And now, if I say question mark, it's asking for wildcard. Mohammed, you were asking for wildcard area, and I did say that we will come into it as we go closer. Now, I've put in an IP address for a network, okay? But I need to specify how big that network is. And in my case, my network is /24. That means it's 256 IP addresses big. So I need to specify that by giving the correct wildcard. And the wildcard is basically it's the reverse of your subnet mask. Okay, you can actually look at it that way, but it's done by subtracting it from a broadcast address. Okay, so the mask now will be 0.0.0.255. Okay, I think I've got enough zeros in there. We'll find out if it doesn't work. Okay, so I've done my wildcard. I'll ask, oops, what else do I need? And it tells me, put in a destination address. Okay, well, my destination address will be here. Okay, so I'll put in same 168.3.0, and again ask for the wildcard. Again 0.0.0.255, and ask what else do you need? It says that's all I need. So you can say hit return, and that is accepted. That one. Now the first line I've permitted traffic from inside here, but I need to deny everything else. ACLs have an explicit deny all, but normally I would actually put it anyhow. Okay, so I'm going to say access list 110, deny, I'm going to say IP any packets, IP source address any, and where is it going? It's going to my final destination 192.168.3.0, and it's going to ask for the wildcard, which is 0.0.0.255. Do you need anything else? No, thank you. There you go. Okay, so hopefully that will work. If it doesn't work, well, we'll need to. I'll find the time to actually correct it, but never mind. Okay, now I have to apply the access control list on this interface, G01. Okay. So I need to enter into the interface G01. Now that I'm within the interface, I need to apply it using the IP access. I've done this before, so IP access group 110, and it's going to ask which direction. Okay, the instruction says it's on the incoming traffic to this interface. So anything coming in here, trying to go in there. So I'll say in, and I hit return. Okay, this is applied now. Okay. Okay. Number 6, apply another or use another access list 100. So the first one is done. First one is applied. Second one needs to be done. 100 is still within the range of the extended access lists. Okay. Now within this one, it says block all packets containing the IP address from the following pool. So I have kind of big groups of addresses I need to deny and block. The private addresses, I've got private addresses in class A, B, and C. Okay. Let's just quickly get this one done. Let's go on. Okay, sorry, I just need to enter passwords again. Let's go NPA55. Okay. All right, so the extended 100 is still within the extended range. So if I say, what else do I need to do? It says deny. Okay, I've got class A, class B, and class C. So let's deal with the private addresses first. Or hang on a second, let me just complete reading. Otherwise, I don't make mistakes I tell students not to do. So I've got another bunch here for 127 and the multicast addresses. Now, since PCC is being used for remote administration, permit SSH traffic from this network to PCC, right? So I do have a permit. So I need to permit those first and then deny the other ones, okay? So let's permit, and it's traffic coming in from certain host, 192.168 3. Not 3. 2.1, and it's going to destination. Okay, well, since I have the management destinations, I'll say host. Okay, and that's destination IP address 168.3.3. Okay, I think that's all. Okay, and then I'll also do the other one. Oops. So 10 to host 10. Okay. Now I'll need to do my, there it is, my blocking. Okay, so access list 110. Oh, sorry, 100. I need to deny, and I need to deny any IP address coming from a certain pool. Now, the first private IP address is 10.0.0.0. Now, the wildcard for that is 0/8, isn't it? So 0.255.255.255. And that will be going towards which host destination. So host, and I'll give the PCC to 168.3.3. And that's it. It's the first one. Now the second pool, I'll just repeat this with the different pool. So take these out. I have to be very careful about the actual writing of the addresses, otherwise they will mess things up. The second one is 172.168.0.0. Oops, 0.0. Okay, I have to wake up to what I'm actually trying to do. That's a /12, so 0.15.255.255. And again, going to this host. So this is the second private IP address bunch. And now the third one, I'll just take them off from here, save me a little time in typing. 192.168.0.0. And with this one is /16, so it's 0.0.255.255. Okay, I think I've done it right. Okay, so now all private addresses have been done. I need the 127.0.0.0. So again, deny, change the range 127.0.0.0. And it's a /8, so it will be 0.255.255.255. That's it. And then the last one is the multicast. Multicast is from 224 up to 2339. So I'll need to change this. 224.0.0.0 with a mask. Now let's try and work out this mask. Right, it's 224. So it's 15.255.255.255. Hopefully I've done the calculations right. Okay, I've done my permits, done those, configure them, use access list. Okay, so it looks like they are all done now. I need to apply it and then test it. Okay, apply it on serial 00. So interface 0, 0, 1. And then I'll say IP access group 100. And that needs to go in the inbound direction as the instructions ask me to do. Set that. Okay, now I need to confirm it. Okay, confirming it says from PCC command prompt ping PCA server. Okay, let's try. Okay, ping PCA server, which is one correct. Okay, unreachable, unreachable. I can't get through because of this access list on my router 1. Okay. Okay, router 1 is blocked. Establish SSH session 2192. Okay, to this router here. SSH to that. Okay. That's not going through. That's not responding. It should, okay, it's not responding now because it's blocking any, no, it needs to go out. Correct me if I'm mistaken. I've put in an access list in there and it stopped traffic from coming back in, but it did not stop traffic from going out. So here I am, okay. Not that one, this one here. Sure. Or just make it bigger. Can you all see the lines? Okay, yeah, big enough. Okay, good. Now this is the list that I actually have. I've got 3 different types or 3 different access lists in here. First one is just a standard one. Okay, this just deny hosts except for deny access to these except for that one. 110 is permit traffic coming from this network to go to reach that network. And why is that permitting? Okay, that's a source. Okay, now. Okay, I'm just double checking this. 110. Okay, there's a mistake I've done. That's why it's not working. Okay, access list 110. So let me just correct it quickly. Okay, let's say no, I'll just negate it. Easy thing to do will be to just take it out. Copy it, paste it. Okay, now I need to write access list, and it's 110. I need to permit. Oops. Permit. Okay. Let the IP 192.168. Oops. Okay. A55. So permitting 192.168 3.1, doesn't it? 3.0 with a wild card of 0.00255, and that's any. Okay, let's have a look, see if that works. Okay, my mistake, I just written it wrong. Okay, so now that is successful. I can go Cisco SSH PA5 on. I've got access from there into there, which is good. I know it's been a little long. I'm gonna stop right here. Okay, I didn't mean for it to go this long, but it did. However, at least we've done that successfully and has gone through. Is there any questions to what I have done so far?
Usama, it's like we have 30 minutes left. I mean,
Yes.
I have no idea whether it is good to have if there is a point of having a break now or if
No, it's not. I don't think it is. I have gone a little too far. This is taking a little longer than what I expected to actually do.
Okay, so there are some questions in the chat from Otman. Otman, please share your audio or put them in the chat if you cannot share your audio.
Yeah. Let me just stop this for now so I can actually see what questions there are, because I couldn't see the questions earlier.
دكتور عثمان بإمكانك طرح الأسئلة أو وضعها في الشات إذا بتقدرش تشغل المايك.
Why did you choose ACLs instead of firewalls? That's a question, Dr. Otman. Well, ACLs actually work within firewalls. Firewalls use ACLs to actually filter the traffic and allow traffic either to go through or to drop the traffic and stop them from going through into the network. So when we're using ACLs, when we're talking about ACLs, we're actually talking about firewalls. Now, firewalls could be implemented within routers. They could be implemented within a host, i.e. personal computers, or they could be as a standalone hardware firewalls, but they all work with the same concept of ACLs. There are loads of different types of ACLs. I've chosen some in here to give an example of, but the subject is still big. It's still quite quite large to cover within this limited time that we have. I hope I've answered your question. Okay, excellent. Let me see if there is any more. Okay, I've enlarged that one. Is there any other questions? Okay.
Seems no questions.
Okay, I don't see. I'm just scrolling through the chat to see if I've missed anything, and I don't think I have missed any other questions. If there is any other questions, well,
but
hang on.
in fact, again, the same question.
Somebody,
how we could use this knowledge for the freelancing? In fact, it's not my field, the IT, but I'm the project manager, and we have to organize some courses for the graduates,
right,
to enable them to work online using such modules.
Right.
So how we can use the teaching material or the modules you discussed today for the freelancing?
Okay, right. Let me take it and answer that in two kind of separate sessions. First, to teach the actual courses. To be able to actually teach the courses, you need to be able to be certified as an instructor, be it in Cisco or Huawei or whatever. Okay, so getting that certification is a must to be able to teach it. But to do that, you need to get the certification, or need to be able to be certified as an engineer, or as a network engineer, or security engineer, or whatever. Okay, and that you need to study it. Now you can study it online by applying for these courses, and you'll be able to actually do the studying fully online. With one exception, is that the actual testing needs to happen within a certified test center. That will be locally or to the closest geographical location to where you are. Okay. Now, once you've passed the certification test, then you will be able to actually work freelance in industry as a network engineer or security engineer, and have some credentials behind you for employment. Okay, but if you're thinking about actually teaching this course, then first you'll need to actually get the certification as an instructor within the industry. So you, for example, for Cisco, you need to be able to get the Cisco certification as an instructor, or for Huawei, or for whichever other technology.
I'm sorry, Usama, if I could come in here. Abdullah, I think his name was, you asked this question previously, and I think I understand now a bit more why you asked the question. You know, correct me if I'm wrong. I think what you want to be able to do is, rather than using proprietary software to deliver this sort of content to your students, you want to be able to use open source software. Now, I'm pretty sure that's what you're after. And if that's the case, if you think back to my presentation, I talked about using Open Daylight, for example, the Open Daylight controller, which is run by the Open Network Foundation. That allowed me to build my initial SDN platform by using open source material. And I was able to leverage Mininet, which was another open source application, to create my virtual switches and virtual routers. Now, you know that Linux is an operating system that is free. So there are a whole bunch of tools that you can use on a Linux environment, you know, such as Ubuntu and the rest of them, that give you all the network applications that you require. Yes, it's possible to also use GNS3 in place of Usama's packet tracer. GNS3 is also free, it's open source, it's just a bit resource hungry. So in that case, you want some extra CPU and extra memory. Again, use Google's free Google Compute service for $300 up to 120 days. You know, so there are all these free tools you can leverage. If you want some more information about this, you know, we can supply that to you after the session.
Okay, thank you, Bliss.
May I state the question of Dr. Sadiq in another way, please?
Please, Dr. Radwan.
Yeah, I assume that, okay, the technical presentations for today was interesting on technical level, but the idea is how to highlight the main skills required by the international market, so as to pass through to our students, so as to concentrate or to be certified with. So what we need is a list of competencies or skills that are required by the international market, so as they can present these skills to the companies or to the outside companies, so as to be requested as freelancers or to work with them from Palestine. So this may be the basic idea of having more technical highlights about what is needed in the international market. I don't know if I can explain this to our colleagues, rather than having okay, all of us have Cisco academies, all of us have some way or another to teach what we have as sessions in today's provided that it was very interesting. I mean, on a personal level, it was very interesting lectures for today, but it is specific to a topic. What we need is to pass the required skills to our freelancers or to our graduates, so as they can get ready or get certified or get in depth and skillful to provide these as a work for them.
Usama, do you want to take that question, or
yes.
do I field it?
No, I think we filled it before, but I mean, we've talked about the free lance or the free source side of certifications, which can be got at or can be used, as well as the proprietary certifications, which are being used now quite extensively within industry. So whether it's the free source or whether it's proprietary, in either case, a certification to testify to the skills of the individual is needed to be able to actually get a foothold, more or less, on industry, to be able to actually work on a freelance basis as engineers or as IT specialists. So, I mean, these are available. We can provide some of these at the end. In some cases, we at Middlesex, we ourselves are certified academies. We can teach towards these or some of these certifications as needed. It's all a matter of preference on individual, but these we can actually provide at the end of the sessions, by all means. I don't know if I covered everything, Clifford, or not. So if you've got something else to add, maybe.
Yes, just very quickly, specific to Dr. Abdullahi, I think it was, talking about the skill sets. Well, these sessions today are specific to topics that have been chosen. However, I think what you also need in addition would be some sort of career path. You know, for example, you know, a student who wants to become a network engineer would have to be able to provide or meet certain requirements as prerequisites, you know, as skill sets to be able to seamlessly join industry and be able to work. So I think that's what you're looking for. So, and I think that would be something George and others might want to discuss, maybe to see how we can.
Thanks, Cliff, because it's. I was going to get into that. Okay, you need to see the entire week of trainings that we put together, and we will discuss certain things. I mean, Sadiq, I think this is also something that we need to explain to other European Union partners in preparation of the other trainings. If you'll see the agenda, we created a list of trainings for a wide range of topics. So within 3 hours, we will not be able to cover everything. So what we did is like we did a flavor of if you like, of how we teach and why we teach it in that way. So I mean, that combined with the visit to London, where the guys will show you the infrastructure, but also how they actually teach in a way that, I mean, for example, if you see Cliff in the lab, they're not just showing what they're showing to you today, but also discussing in a way that how the students will have to be a member of a team, how to convey themselves when they do the professional work and so on. So one of the things that I'm doing tomorrow, it's a combination, my session followed by the MDX work session. Rather than teaching you what an entity relationship diagram is, which is one of the things that I was teaching in the first years, I'm going to show you the elements of how we use, if you like, the learn how to learn in order for the students to be more independent. So you have to realize that it's a combination. So today, what we've done is like on networking, and I'm happy that if my colleagues want to say more about the technologies that we need to use for students to be able to work in freelance contracts, that would be useful. For example, on Friday, Ariadne is showing Tableau. And the reason why we show you Tableau is because this is the technology that most of our students, the graduate students, use if they want to go freelance or on placement. Now, on Thursday afternoon, we have machine learning, which is from a theoretical perspective, but in the morning is how you work with data, and then we can actually test some ideas. Tomorrow, I really want to focus. So tomorrow you will see me jumping from one lab to the next, so we can show you how I teach the students, how we give them feedback using a technique or with a template, so they can get that feedback, because I try to work with them in a scenario like they're a member of a virtual team. So basically, I will also show you the approach of how we use the hybrid teaching, because basically that will help the students to be more independent. So we touch that. One of the things that we need probably to focus more when you talk to the specialists like Cliff and Usama is to ask them what are the, not necessarily the skill sets, but what are the technologies, what is needed out there in the market. And that we were hoping to do more in the follow-up discussions that you will have when you come in the campus. So when you come in the campus, Usama and Cliff, we can arrange for an hour to have a meeting with them, and then like they can actually say, okay, in network, or we could do a focus group and say, okay, this is what you need in the network area for freelance and so on. So do not think that we can actually within every 3 hours to go freelancing network, freelancing data. It's almost impossible, but at least you understand what we try to do with this week. Okay?
Yes, understood, 100%. Thank you.
Thank you, George.
Osama, are you going to teach anything else? We have actually, you almost killed everybody.
I know. I
don't know where you get the energy, man. Seriously, I was like, after a certain point, I could just see you type and say, oh my God. So,
apologies for the time. It's just ran out. I mean, I prepared a lot more. It's just the 3 hours is just nowhere near enough.
It's money well spent. Usually people try to have breaks. We don't give breaks. This is why we
do. I mean, I've completely kind of missed out on the other. I will have the slides available for everybody,
Please.
although I did not go through them.
Please have the slides available. And
yes.
when our friends come to London, we will have a follow-up.
Maybe I'll have a follow-up on that. That's to cover cybersecurity.
I'm going to stop the recording then now, and we'll call it a day.